All right, today we are diving deep into a project called TaskWhisper. It's a fantastic example of how a modern application evolves, step by step, from a pretty standard web tool into this powerhouse cloud-native AI system. Let's just jump right in.
I mean, how cool is that? Just whisper it, done. That's the core promise right there, and it's so simple, but so powerful. What if you could manage your entire to-do list just by talking? This one little phrase really sets the stage for a super ambitious goal.
Okay, so here's the game plan for today. First, we're going to meet TaskWhisper itself. Then, we'll look at how the foundation was built. And then, this is the fun part, we'll see it get an AI brain. After that, we'll cover its big move to the cloud, and then dig into the secret sauce, this spec-driven blueprint for how it was all put together. And finally, we'll wrap it all up and see why this project is such a big deal.
First things first, let's meet the star of the show. So what is TaskWhisper, really? And what makes it any different from the dozen other to-do apps you've probably already tried?
So at its heart, the whole idea is to just get rid of the keyboard and mouse, or at least make them optional. Instead of clicking little boxes and typing into forms, you interact with your list like it's a personal assistant. Think about it. You can just say, hey, add finish the report to my work list, or what's on my plate for tomorrow. It's all about using natural, conversational commands.
Now, what's really interesting here is that this project didn't start with all the fancy AI stuff. The philosophy was brilliant, and it was simple. To build a great, smart app, you've got to build a great app first, period. So let's take a look at that rock-solid foundation, which they called Phase 2.
And this timeline, well, it lays out the whole journey perfectly. You can see it starts as a complete, fully functional web app in Phase 2. Then it evolves, gets smarter by integrating an AI chatbot in Phase 3. And finally, it really matures into a system that's ready for massive, real-world scale using Kubernetes. You see that, right? It's this really smart, logical evolution from a solid product to an intelligent, scalable service.
So get this, before a single line of AI code was written, TaskWhisper was already a legit production-ready app. This means it had secure logins for users, the ability to create, read, update, and delete tasks, a design that worked great on your phone, and, this is crucial, it made sure your tasks were completely private to you. This wasn't some flimsy prototype, you know? It was a real solid product from the get-go.
And the tech stack it was built on? Top-notch stuff. We're talking Next.js for a really slick and fast user interface, a super speedy fast API backend, and a totally reliable PostgreSQL database. This means this thing wasn't just solid, it was basically the perfect launchpad for everything that was coming next. All right, so we've got our rock-solid foundation. Now it's time for the big leap. This is where it gets really cool. Welcome to Phase 3, where TaskWhisper gets its brain.
So you might be wondering, how does the AI actually do stuff? Well, it's not magic. It's actually pretty clever. The AI is given what you can think of as a tool belt with very specific functions it can use, like add task or list tasks. So when you say something like, show me all my urgent tasks, the AI is smart enough to pick the correct tool, list tasks, and use it correctly.
Let's walk through how this works, step by step. First, you send a message. Then the AI model, in this case Google's Gemini 2.5 Flash, which is super fast, figures out what you want. It then grabs the right tool from its tool belt, performs the action in the database, and then, and this is so important, it talks back to you in plain English to confirm it's done. It's a really simple, elegant, and effective loop.
Okay, so what does all this tech actually feel like when you're using it? Well, you get to see the AI's response in real time as it's thinking. Your conversation history is saved so the AI remembers what you talked about earlier, and you can seamlessly switch between talking and typing. It just makes the whole experience feel so much more natural, so much more human.
So having an AI brain is awesome, right? But for a real app that people are going to use, it needs to be tough. It needs to be scalable. And that brings us to the final stage of its evolution. Phase 4, getting ready for the cloud.
The whole goal here, make this thing absolutely bulletproof. You've probably heard of Docker and Kubernetes. Here's a simple way to think about it. Docker containers are like these perfect little lunchboxes for each piece of the code, making sure they run the same everywhere. And Kubernetes? Well, Kubernetes is the orchestra conductor, making sure all those lunchboxes are playing together in harmony, replacing any that break, and adding more if a big crowd shows up.
Now, the real genius of this cloud-native design is in the separation of powers. The different parts of the app, the front end you see, the back end that does the work, the AI server, they all run in their own independent units called pods.
This means if one little piece has a problem, it doesn't crash the whole party. That's what makes it so resilient and flexible.
So, okay, technical jargon aside, why should you care about this architecture? Because it delivers some seriously powerful, real-world benefits. I mean, think about it. If something breaks, Kubernetes just restarts it automatically. That's self-healing. If 1 million people sign up overnight, it can scale up instantly to handle it. It's super efficient with resources, and it's secure by design. This is what being cloud native is all about.
Okay, so we've seen what TaskWhisper is and how it's structured. But the story of how they built it, well, that's maybe the most innovative part of this whole thing.
This project was built using a really cool method called spec-driven development. I love this analogy. Imagine an architect who draws up incredibly detailed blueprints for a house. In this world, the human developer is the architect. They write these super detailed specifications. And then, these specialized AI agents, they're the construction crew, taking those blueprints and actually writing the code.
And to make this whole system work, they basically created 2 kinds of building blocks. First, you have the AI agents. These are like specialized workers. You might have a Kubernetes expert AI or a database setup AI. And then you have skills. Think of these as their power tools or maybe like reusable Lego bricks for common jobs. This combo of specialized builders using standard parts makes the whole process incredibly fast and consistent.
All right, let's bring it all home. After seeing this whole journey, what are the big takeaways from the TaskWhisper project?
You know, one of the true signs of a great cloud-native app is just how efficient it is, and this chart shows it off beautifully. Those container images, our lunchboxes for code, are incredibly small and lightweight, and that means they start up faster, they deploy quicker, and they use way fewer server resources, which directly translates into speed and, you guessed it, saving a whole lot of money on server costs.
And just to really hammer this point home, the entire backend, with all its AI smarts, is packed into an image that's less than 500 megabytes. To give you some perspective, that's smaller than a lot of updates for a video game on your console. In the world of complex enterprise software, that is ridiculously lean and efficient.
So at the end of the day, TaskWhisper is so much more than just a slick to-do app. It's really a powerful case study. It gives us a clear roadmap for how to evolve an application. It proves this model of humans as the architects and AI as the builders. And it really highlights why having a cloud-native foundation isn't just a nice-to-have anymore. Honestly, this feels like a real glimpse into the future of how we're going to build software.
And that really leaves us with one big, important question to chew on. With humans providing the vision and AI doing the heavy lifting of writing the code, could this spec-driven approach be the new blueprint for how we build the software of tomorrow? Thanks for sticking with me on this one.